Alright, in this section here we're going to be solving nonlinear systems of equations. And of course we can't read the whole thing here, I'll have to move that. But this says solve this nonlinear system for x and y. So once again we're solving for x and y in this system here. Write the solution I've got as an ordered pair is actually what it says. We can maybe move this over as an ordered pair. Okay. And we're going to write it as an ordered pair, x and y. We could graph these and see actually what the graph actually looks like and what we're really looking at. And I think what we're going to do before we actually solve this system, I'm going to go ahead and graph both of these and so you can see this geometrically. Alright, so this is the x squared here, the blue line, and the red is y is equal to 5x. So we're looking at where these two graphs intersect. Well, you can see that they intersect here at the origin, and I'm going to have to do some serious moving on this graph. And you can see that they intersect right here, and I'm not exactly sure what that is. This looks like 20 here, so anyway, we're going to find out what this point of intersection is. So you can always graph these things and definitely get an approximation if you had to go that route. But okay, well, let's go to the whiteboard and work this out. Alright, so we're going to have, we had y is equal to x squared and y is equal to 5x. Well, in order to solve the system, best thing for us to do is since both these y's are the same, right, we can just set these guys equal to each other. X squared is equal to 5x, and then I'm going to take the 5x over to the left hand side. Alright, so back when we were factoring polynomials and solving quadratic functions and all that kind of stuff, this is what we were leading up to, really. Alright, of course there will be some application problems that come along with all this stuff. But here we are. Let's go ahead and pull out an x. And then we have x minus 5. So we can set both these factors equal to each other, and that's an easy one there. X is equal to 0, and x minus 5 is equal to 0. We solve for x in this problem, and we got x is equal to 5. So it turns out we have two x values. Now remember where the graph crossed, so we had our graph like this, and it's where the graph crossed the origin here. Okay, let me do this in a different color. And it did something like this. So the graph crossed here at the origin. So the x is 0, and to figure out what y is, we go into either one of these equations. It doesn't matter which one we use. You can use this equation or this one here. To find out what y is, you would just plug 0 in. Right? You just plug 0 in. So 5 times 0, and then of course we get 0 out. So that's one of our ordered pairs. Then we would look at the other x value, which is x is equal to 5. So this must have been 5 here on the x-axis. And to find out what our y value, our second coordinate, is going to be, we would just plug 5 into, it doesn't matter which one we plug this into. So 5 squared is 25, or 5 times 5 is 25, right? So there's our two solutions, and that's where the two graphs intersect. Okay, so let's look at another one. Actually, I think what I was going to do is come here, click on answer, and we get 0, 0, and 525 as our two ordered pairs. Alright, let's look at number 2 here. Alright, so you can see here we have y is equal to 49x squared, y is equal to negative 98x minus 40. So we're going to do this the same way. We're going to set them both equal to each other, and then we're going to solve for x. Now in this particular problem here, this is going to be a little bit more difficult, but if you followed some previous sections, you should know how to work this problem. Alright, so let me get this written out here. We have y is equal to 49x squared, and then our other equation is y is equal to negative 98x minus 40.